Hey, hello everyone. Welcome to the new session of Quick Hands-On. So, in the last session, we discussed about Word2Vec and its application in the context of Game of Thrones, cricket, politics, and today we are trying to extend that. But before that, I want you to see what will be our end product, how our end product will look like. So, this is a question answer demo. So, here we will put a paragraph, and depending upon that, we'll give some certain questions, and depending upon that, it will try to find out the answer out of this paragraph. So this has been developed by Priyanka Divedi. So we are just using it. So what, like, I just copied a one answer from Quora, like what's the data scientist, on like that particular answer. I just copied it, and depending upon that, I just created some random questions like what is a data scientist job, what's the role of data scientist, and it tries to find out the context of that particular question and tries to answer that. So like the data scientist job is to first understand the existing business process. Similarly, it gave the same answer, like data scientist job is to first understand the existing business process. Similarly, what is the role of data scientist? So data scientist role is to be an expert in application, so it gave the same thing, to be an expert in application that are derived from stats and computer science. I just gave one random question like what does the basement have, and it is giving one some random sentence out of the paragraph. This we can improve in future, like if the paragraph, if from the paragraph we are not able to answer, we can give some like we can give like it's not answerable or something like that. This can be improved in future, but currently we'll just try to build this particular demo that we are viewing here. So okay, so before that, as in the last session, we you might have remembered like this we did where we compared WordNet with one WordNet, then one hot vector, and how Word2Vec is solving all those problems. And then we discussed about how we can map that and also visualize like the same particular context words are getting mapped in the same vectors, like at the same vector space. So, and this is also uploaded in GitHub, so you can just go and try it out. Now the next thing is that what we are trying, like in the previous session we saw already pre-trained vector that we used, and to understand how that can be applied in any particular context. But now we want to know how to train a Word2Vec, like how we can train a Word2Vec depending upon our own use case. So as in the previous example, the pre-trained vector that we were using, that was trained on different type of scenarios. So we want particular Game of Thrones Word2Vec, like the Word2Vec that has been trained on Game of Thrones. So I'm just using this. This is from the repository, Siraj Rawal's GitHub repository, which I am using currently. So what, like, but it like if you'll just fork his repository, that like I think that has been uploaded earlier. So there are many like this won't work directly. So like this one, which I had to make certain adjustment. Like there was many deprecated modules or libraries that were being used. So depending, like we were not getting, like I was not able to get it run, so I have to make certain adjustments. So this is the current working Game of Thrones Word2Vec. So I will upload this particular also on GitHub, so you can just quickly go and can use it. So what we are going to do with this particular thing is that, as we have understood where the Word2Vec can be applied and how the Word2Vec can be applied, now we will understand that how we can train the Word2Vec as per our own use case. So okay, we'll start now. Yeah, so first we'll import the future because like to make it work for both Python 2 and Python 3. Then we are using codex to handle the encoding stuffs, and globe to handle the regular expression in path names, logging for logging thing, concurrency like multiprocessing for parallel CPU processors and all. We'll use concurrency for multiprocessing we'll use, and then OS for path in the file system, pprint for human readable format reading, RE for regular expression, and LTK for yeah, simple, like we are going to use like tokenization and stop words, so that we'll use. Then Word2Vec model is there, then SQL and manifold is there for dimensionality reduction that we are using, NumPy for again for math for Python, and plotting we are using matplotlib.pyplot, pandas is there, and then Seaborn for visualization we are using. Okay, so NLTK, then we are using, and from we are downloading two things, punct and stop word. So punct, we'll be going to use this for tokenization. Okay, so we'll first get the book names, like all the book names that are present. So this is the directory at which the book names are present. So we are just using this and we are just displaying. So these are the books, like 5 books are there, GOT1.txt, GOT2, and similarly GOT5.txt. There are 5 books are there. So Okay, now this is our first step. So in the first step, what we are doing is that we are initializing the corpus raw. It's a big, what we are trying to do first understand what we are trying to do this in this cell. In this cell, we are trying to add all those sentences or all those files or all those books in one variable, like in this corpus raw we are going to use and make it as one thing. Okay, so we are going to, okay, so first we are initializing with raw, like this unicode. We are initializing it, and then we are reading from the book file name. So book file name is the book in which we had added those things, and then we are reading from, like, added the name of the book files, and then we are reading from it. So while reading, we are using codex and converting into UTF-8 while reading. But while and in this, while writing into this corpus, we are using in Unicode. Okay, but while reading, you have to convert it into UTF-8. Okay, so yeah, so now the corpus is as like first got1.txt has been read and has been added into the corpus, right? Here we are adding it. So then this is this much character long, and like at every iteration the characters, the new got.ab 1 2 3 4 5 is getting added, and the number of characters are increasing accordingly. So now we have one corpus, one big corpus, which has all those text that are present in different files. Like earlier, got1, got2.txt, got3. Earlier it was like that. We have added all those things, all those content from all those 5 files into one variable here, corpus raw. Okay. So now the next thing is that we have to create a tokenizer. So as I have already told that we have already downloaded the punct from NLTK. We are using this it's english.pickle because it's like the language of the book is in English, so we are using english.pickle. So pickle is the like serialization format which is used in Python. So we are using that and we are loading it into a tokenizer variable. So now we are tokenizing it. Like the corpus raw is a big, yeah, this is the variable in which, like, it's a big huge memory containing variable is there, and which has all the contents of the 5 books, and then we are tokenizing it with the help of tokenizer and storing each, like we are tokenizing it in the sentences. Like every we have different tokenizing it into several sentences, and then like storing all of those in the raw sentences. Then then here we are trying to split the we are trying to split those things into words. Like every sentence will be splitted into words. So okay, we'll just see. So if we will take this sentence, heraldic crest by Virginia Nore. So this is the sentence from the real got txt. Okay, and when we are passing this some particular sentence to this sentence to word list, it is tokenizing or creating, splitting that particular sentence into words. This is what this particular function is doing. Okay, now how we are going to use this function is that we will first use like we initialize one sentence array, and then we are using every raw sentence from the raw sentences, and if its length is is greater than 0, then we are calling this particular function on this particular sentence and appending it into a sentence array. This is how we are doing. So for every sentence it will be created like this unicode. This for every sentence it will be created like this, and every sentence will be appended into sentences. So sentences is this array, and every sentences words which are been like splitted by like this would be uploaded for every sentence into appended for every sentence into the sentences variable. Then this is the number of tokens that we have. Okay, so now we have to define the model. We have to build the model. So these are the hyperparameters of the model. So number of features. So as in the previous video we had discussed about the number of features that we can use to define a vector for a word. So like 50 dimensional, 100 dimensional, 300 dimensional. So as much dimension as it is, it will be more accurate. So here we are using 300 dimensional. Then we are using minimum word count as equals to 3. Then number of workers. So this is for multi-processing thing. So we are using number of workers as much as the codes are available. We'll assign it to the number of workers. Context size is equal to 7. So context, this is the window length, like how many words from the current word, like from the target word, we'll consider as the context size. So if anyone is finding difficulty to understand all these parameter, I would advise them to go to the playlist Understanding Like a Pro. So this what I had started to get into the depth of every model and get into the detail of like the math that is involved in the model. So I have discussed about all those context size and all those things into that. So I will I would recommend you to go into that. I'm also trying to cover a little bit into this as well. So here we are using context size. Context size is the window of the words that are around the center word, target word. So like let's say I met him. Okay, so I met is a context for him word. Him, if him is the target, then I met is the context. Or I met him yesterday. So if him is the target, then I met and yesterday is the context. So something like that. And if you define as context length equals to context length equals context size equals to 1. So one word before the target and one word after the target. So met and yesterday will be the context for him. Okay, so then we are using downsampling. So downsampling is if for the more frequent word to reduce its effect in the particular model, we are using the downsampling thing. Again, this I had explained into that understanding like a pro video, so I would recommend you to go and see that. Okay, so now we are using all those hyperparameter to define the model through Word2Vec. Okay, so now the sentences. So as you remember, like the sentences is the variable or the array which has all those sentences in which every sentences is splitted into words. So this is there, and okay, so then we are building the vocabulary on that particular sentences. So the vocabulary length is this much. Okay, now we are training it. So I have just used epoch equals to 2 just for like to get it done faster. You can use it as per your wish. So as much epoch as you will use, it will have more it will be giving a more accurate result. So yeah, we can do that in that. And then once the model has been trained on that particular corpus, we are storing it into the trained folder, trained directory, and then we can again reload the model. So if you want to know also like how we can save the model, how we can reload the model, here is the like you can use this particular method to load or to save and then again reload it. Okay, so now our model has been trained on our own use cases data, like our own Game of Thrones books data. Our model has been trained on. Okay, so now we will use our TSNE for its like squashing it and creating a two-dimensional vector so that we can visualize it, so that we can understand it, so that we can analyze it. So first we'll define the model here. TSNE model is there, and then okay, so this is the model which we trained on our GOT books. Okay, and then we are using its okay. So earlier for model.sin0 will give that vector, all those vectors, but currently now it has been changed, so you have to use .wv.sin0 to get all those vector representation for the books of text that we had used to train the model. So all we are saving it into a big matrix, giant matrix, all world vector matrix. So all the vector representation of those words we are storing into that all world vector matrix. Okay, so this is how it looks. Yeah, so now we will try to fit our TSNE model into on that particular vector matrix. Okay, and then we are creating the pandas data frame for that. So this is giving the position for each word. So if font is there, so x and y coordinate for each word that is present in the GOT books. Okay, so this is how the distribution looks like. Okay, so now we are again the thing that we did in the previous time, we are going to do again. So if we are like the most similar word to Stark will be adult, Brandon, Winterfell, like where they lived. So this makes sense. Again the same thing here is there. Then direwolf, we are using the Hodo, peak, gaze is there. Okay, let's move to the more interesting part. Okay, yeah. So as in the previous case, we are in this also we are doing like similarity thing. So as Stark is related to Winterfell, as Star is related to River Run. Jamie is related to Sword, as Cup is related to Wine. Arya is related to Stark, as Song is related to Dragons. That is very like profound thing if you try to understand. Then this Tyrion is related to King, as Sam is related to Jon. So Tyrion is used to like give suggestions to King when Joffrey was king. In the same way, Sam is try like a friend or a person who advises Jon Snow. So I think this somehow like summarizes how we can train our own Word2Vec model depending upon our own use case by using our own data. So this is how we can do that. And okay, so what we have also visualized this particular thing. We have also visualized how what is our end product will look like, and we have also like saw how we can train our Word2Vec, depending on our own use case. So okay, this is there, and from this week we are starting something known as Rockstar of the Week. So what we'll do here, okay, so what we'll do here is that for every week we will have a Rockstar that is depending upon how much you are contributing towards this particular family, AI Charcha family, how much work that you are doing at your end that like helps or strengthen this community, how much you are helping people of this particular community or particular family of Eva family, and like to learn particular concept if someone is not knowing you, or how much you appreciate their work, because we are trying to build a community around it, like so that everyone can learn and grow. Okay, so it all depends upon your efforts towards this particular cause or particular purpose. So for this week we have chosen Vishwa for this week as a rockstar for the week. So this is a LinkedIn profile. This LinkedIn profile will also be present in the description of this particular video. So actually this particular channel has been visited by most of like many senior data scientists, and like they used to see the videos, and they're in so I think that it would be very helpful if you are in the field, like if you want to get into this field or you are searching for your jobs. So if you have some work, if you are doing some work, like we are having this quick hands-on series. So if you are going and implementing these things at your end, okay, so we can just you can just let me know if like I'll compare all those solutions that I'm getting, and the best solution I'll try to, like if it is more than one, I'll try to include as many as possible as a shootout for every week as a rockstar of the week. And I will also link their LinkedIn or GitHub profile in the description of the video, so you will have more visibility in this market. Okay, so thank you so much for going through this particular video.